Hello friends, how are you? Today increase or decrease the speed of this feeder. This is a input output control card. All the inputs and outputs are terminated in this control unit. This is the main chunk control unit. Which is on the remote, so it will start from the CCR in the center where it is showing 0. It's on the off position, and when I will rotate it to the right, it will be on auto, and when I will give a pulse, it will be started. So on remote we will have to move it little more to the clockwise side. This is speed control. Here we can control the speed of belt unit from field just for checking purpose. You can see this is a VEA 20100. It's input output card unit. Here you can see its supply. It's 24 to 2 and this is a communication jack, so we can communicate with this controller through this. PSC 20100. Of X6, and then the load cell is terminated. Here you can see this is card for local switch interface, local selector switch, and speed regulator. Both are connected with this electronic circuit and then connected to the system card. I am giving you just overview. This is a memory card. All the parameters are saved in this card. This little unit, it's a memory unit. We will communicate with this card. We will check its parameters. and we will check how to calibrate it. This is a load cell, you can see it's PWS 100. That means it can measure weight up to 100 kg, and you can also see it's 2 millivolt per volt. That means if we will give it 1 volt and 100 kgs put on it, it will give us cable with this controller. This is VSC card, and I will connect this cable with the laptop, and through software I will check its parameters and I will do the calibration. This is very easy, friends. You will understand it that this is very easy process to communicate it with the laptop. Now I am opening the software. It's easy, sir. You can see it's showing. I have opened this software. Now I will go into this connection. You can see connection as mouse is moving. Arrow, you can concentrate on arrow. Connect. I will go into the connect, and then serial COM1. Serial COM1. It's showing that it is connecting. Identifying. It's identifying. This is showing that no scale found. Oh, my cable was not connected properly. I connected it properly. Now I will again connect it. You can see I am going into the connection, then serial COM1 connection, and then serial COM1. This is very easy. Now I click, this is connecting. You can say it's loading, loaded, and now it is connected. You can see my laptop is connected with my this easy surf and with this controller. Now I can check its parameters. I can configure the parameters, I can change them, and I can do the calibration with the laptop. You can see it's showing software version, hardware version, and you can see file, edit, view, connection, tools. These are all parameters. There are modules of the parameter. Here you can see downside. Here the fault appears. Here fault appears. Again I am showing you the parameters. You can see numbering 1 2 3 4 5. These are blocks. Each block has different parameters. This is a lock. You can see this is a lock. When I will open it, then I can change the parameter and then I can do the calibration. Now in the view, I am viewing scale operation 1. Scale operation 1, as we have only one wave feeder, so only scale operation 1 is functional. You can see it's showing normal mode. Here you can see totalizer or reset totalizer 1, reset totalizer 2. You can see volumetric mode, start keyboard mode. Here are the normal running values, relative flow rate, reference flow rate, relative set point, belt load, deviation, speed. All the parameters are showing here. So now you concentrate on this mouse cursor. I clicked it. Now it is in the OP mode. That means now I can operate it with this laptop. Okay, you can see the on off switches green and red are activated now. Before they was not active. Now I can start this wave feeder from this laptop. Okay, you can see this is in stop condition. Speed is 0. Now I will start it. I have clicked this green button. My wave feeder started. You can see now its speed is increasing. You can see its speed. Speed is increasing as this belt is empty. So this wave feeder will run on the maximum speed, and it's now on the maximum speed. You can see I am just showing you how this target plate is cutting this proximity and it's giving pulses. The controller will measure the pulses and hence it will calculate the speed of this motor. The load cell is giving the load and multiplying this load and the speed. This wave feeder gives us tons per hour, that how much material is passing through it. You can see this belt, empty belt is running, and because there is no load, so controller is increasing the speed and wave feeder is running on maximum speed. As you can see the nameplate of this wave feeder, MTD 1421. So this red button, it's now I am stop. I will stop this wave feeder. I press this red button and the wave feeder is stopped now. Now I can change its mode. Now it's in the normal mode. In the normal mode, this wave feeder will be started from the CCR and it will follow the set point from the CCR. So I have just operated this wave feeder from this laptop through this software EasyServe 1.1. You can see now belt is stopped, its speed is 0 and it's showing a little weight. Now I will show you how to calibrate it. I will just make it here, then I will make 0 calibration just to show you. You can see this is a cross, this is a cross mark. It is to reset the fault. If there is any fault, then I will press this cross. This will clear the event and fault will be acknowledged. how to zero calibrate belt wave feeder with Schenck easy serve software. You can see the deviation, that how much deviation was there, and the tear correction, how much tear was corrected. If I will apply it, then it will take the new calibration value and it will be zero calibrated. Friends, I just showed you for calibration this mode. I will change this mode. For zero calibration I will change this mode. In normal it is running in the gravometric mode, but for calibration I will put it in the volumetric mode. After calibration I will change the mode to the gravometric and OP mode into the normal mode. In the normal mode it will run from the CCR, take set point from the CCR. Here you can show it's in the normal mode. There are the reset totalizer 1, reset totalizer 2, one is in the ton and the other is on the kg. So if you will press this reset button, this totalizer will be resetted to the 0. Then there are two totalizers, one is showing value in tons and other is showing in the kgs. So you can see batch select. Batch is just if you want a selected material, you want 10 ton, then wave feeder will stop after giving 10 ton material. So this is called a batch mode. Scale operation 2 is empty because there is only one wave feeder. These are parameters online. It is showing which parameters are configured. I will just give you an overview. Here you can see parameters. These parameters are showing. Controller parameters are showing. Now I will show this parameter block 9. This is calibration parameter. There is a range correction 9.1. If we will change this range correction factor, calibration will be changed. There are parameters, what is basic tear, what is the belt circuit time, and what is the belt circuit number. So these are the calibration parameters. When we calibrate, span calibrate, we adjust this parameter 9.01 as per the calculation. So here I am showing you analog output block. Here we can adjust which output we want, 4 to 20 milliamps or 0 to 20 milliamps, and what is the range, 0 to 100 or like that. The other parameters, it's showing digital input. Suppose I want to configure a digital input. There is external event 1, it's on the VSC card, digital input 1. It is configured alarm. I can configure it warning 1, warning 2. I can configure it IG, ignore. But I want alarm because it is very critical. There is DI. If I will press, this will be deactivated. This is VSC card 1 or VEA1. I can change the card. Just clicking on this, I can change the card. This is digital input 1. I can do digital input 2, digital input 3. Any input you want to configure, I will click here. Normal position is low or high. I can change from here that what is the normal position and when the alarm will be activated. This is digital output module. Here I can change the digital output. I can configure digital output of VEA card or VSC card. If one input or output is faulty, I can reconfigure it on the other input or output, which is spare. As showing alarm, this I am showing you, this is an alarm. I will reset it from this clear event button, which is like a cross. Here you can see it's showing alarm with this red arrow. You can see here it's showing alarm. I will click it. If I want to know from where this alarm is generated, I will click it here and I will click it again. When I will click it, it will open a new window. It will be help window. It will show that from which parameter this alarm is configured. Here I clicked it. You can see showing HTML help. It's showing the fault. It's showing from which parameter this fault is configured. I can go to that parameter and I can check that here. You can see I just press this, it will show its detail that from where this fault is generated. So it's very easy to go to the root cause and to the parameters, so we can trace the fault from where it is configured and from where it is generating. It's very easy. So you can see I can configure alarm, warning 1, warning 2, warning, and the ignore. Warning 1 will show and it will need a reset. Warning 2 will be generated and shown, but it don't need a reset. Ignore means no fault will be generated, there will be no warning on the display. Now I can clear this event from this cross button. When I will press this cross button, fault will be resetted. This will be clear. Event will be clear. I pressed it and now there is showing no event. That means event is acknowledged, fault is acknowledged, and now it's ready to start. After each alarm, we will have to reset it. After that we can start it. I can lock it. You can see there is a symbol of lock. When I will press, it will be locked. Now all parameters are locked. It's just a safety. You can see connection, where I can disconnect it after all my work. I can disconnect it. Then here you can see much material. This material is very dangerous. It should be cleaned properly. Belt should be free. Here is just another overview of another wave feeder. Just for your knowledge, I am showing you another wave feeder. It has a speed encoder that has a speed proxy, but this has an encoder. It is connected with the shaft. You can see it is connected with the shaft. This encoder gives also pulses, and these pulses are counted in the controller and the speed is calculated. Then this speed and the input from the load cell are multiplied and then multiplied with 3.6 and we get the turn per hour. This is a load cell. You can see these wave feeders has two load cell, B1 and